All right, so in this question, we're going to use Excel with our knowledge of what a probability distribution function is and see if we can answer these questions more efficiently. So we're given a PDF, right? In our little purple box on the left, we've got X and we've got P of X. And it's asking us first in part A, is this a valid discrete probability distribution? So we know that for something to be a discrete probability distribution, the sum of the probabilities has to add up to 1. So if I look at Excel, I have like a couple of how-to things, but the first thing that's really mathematical is PDF from frequency. So basically what this does is this, if we had a frequency where instead of probabilities, we just had a number of times, like number of times getting heads, we would use that. So that's not really appropriate here. And our next tab, we do have a place where we can put in probabilities. So we want to use this. So 0, 1, 2, and 3. And then we want to put in our probabilities. So as I'm doing this, you'll notice at the bottom, it's going to keep a running total of the sum of our probabilities. So before I put in this last number, notice that it says at the bottom of our probabilities, 0.9300. So we know that in order for this to be a discrete probability distribution, the sum has to be equal to 1. So once I put in my values from the problem, I see that it equals 1. So I go over here and I say, yes, it is. So now I have to figure out, okay, well, what kind of yes is this? Well, I need the sum equals 1. That's very important. So this first guy, this sigma P of X equals 1, that's what I want. And the second part of it saying each probability is between 0 and 1 inclusive. All right. Then what I want to do is I want to find the mean number of cars owned. Well, Excel actually is going to compute the mean for us. So it'll walk you through all the steps if you want to do this by hand and you can check. But at the bottom in green, it'll give you the mean. So that's going to be 0.8. So mean, expected value, whatever, those are the same thing. And then lastly, it wants you to find the standard deviation. And so we can look standard deviation 0.9055.